This is the second video on completing the square. It'll be a long one showing a bunch of examples, different types of examples. If you'd like to skip through to the different types of examples, that is fine. I'll be following these steps. These are the steps that I wrote on the board on the screen for our last video on this stuff. So copy it down if you haven't, press pause, but I'm going to get going. I want to solve this by completing the square. This time the b value is going to be odd, which we didn't deal with in our last video. Just a reminder, my goal is to take something that has two variables and write it in such a way that there's only one variable, where it becomes like x plus or x minus something squared. Well, the first thing that we do is we move this c value to the other side. So I add a 7 to both sides, and I get x squared plus 5x equals 7. And now my b value is 5, so b over 2, I'm not going to make this a decimal, 2.5. This is actually easier to keep it a fraction. Just trust me on this. b over 2 would be 5 over 2. And b over 2 squared becomes 25 over 4. So I squared the 5, and I squared the 2. The top and the bottom both got squared. So that 25 over 4 is going to go here and here. The left side can factor, and luckily it'll always be able to factor into whatever that b over 2 term was. So b over 2 was 5 over 2, so this factors into x plus 5 over 2 squared. On the right side, I get a common denominator, so 7 over 1 can become 28 over 4, and 25 over 4. And I simplify that, and I get x plus 5 over 2 squared equals 53 over 4. At this point, I've completed the square. My square is complete. But now I want to solve, so I keep going. To get this x by itself, I square root both sides. When I square root both sides on the left side, these kill each other. So I have x plus 5 over 2 equals, on the right side, I have plus or minus. I can find the square root of 4 on the bottom. The square root of 4 I know is 2. So I can just find that and make it a 2. On top, that just stays the square root of 53. This will always happen, where this bottom number here is a perfect square and can be square rooted. And then these numbers will always match, which is actually quite nice. So at this point, I just subtract 5 over 2 from both sides. And I get that my answer is x equals negative 5 over 2 plus or minus the square root of 53 over 2. Which I would actually write like this. And if you give me an answer like that, that is just fine. That's as accurate as it can possibly be. So that's beautiful. Okay, next. We've done b where it was odd. What if b is already a fraction? Here, the b value is already a fraction. You still are going to do the exact same things you did before. First, I'm going to add 2 to both sides. To get rid of that c term, so x squared plus 3 over 4x equals negative 3. My b value right now is 3 over 4. So b over 2 is actually 3 over 8. This is a very simple process. When you find b over 2, you just have to double the denominator. Because really 3 over 4 divided by 2 is 3 over 4 times a half, which is 3 over 8. So b over 2 is 3 over 8. So b over 2 squared is 9 over 64. So I add 9 64ths here and here. Now I have, this will factor into x plus 3 over 8 squared, because this number here is always going to be this number here. Get a common denominator, so I had 9 64ths. I'm also going to have whatever 3 times 64 is, 180, 192. So I have x plus 3/8 squared equals negative 183 over 64. I don't think that fraction can reduce. Even if it could, I wouldn't really want it to be totally honest. Because I want to be able to take these square roots. Take the square root of both sides. kind of switched colors, that's okay. I have x plus 3 over 8 equals plus or minus the square root of negative 183 over 8, because the square root of 64 is 8. Well, right now, that means I have no real solutions. I can't take the square root of a negative number, so this has no real solutions, but that's okay. I'm just going to keep going and find the imaginary solutions. So I subtract 3 over 8 from both sides. I'm left with x equals negative 3 over 8 plus or minus I root 183 over 8. And that's my solution. I keep this split up. There's a real part and an imaginary part. If I could reduce or simplify this radical, I would. I don't think 183 simplifies. Just do 2 more. Here I've got a decimal. Fine, you have decimals, live with it. B is 3.7, so B over 2 is 1.85. So B over 2 squared is whatever 1.85 squared is. Not that one, that one. .7 divided by 2, so make sure I got that right, 1.85. Square that, 3.4225. So I get that x squared plus 3.7x plus 3.4225 equals negative 12. I subtracted 12 from both sides. Left side can factor into x plus 1.85 squared equals negative 12. Oops, I forgot to do my plus 3.4225. So this should be whatever this is. Negative 12 plus my previous answer. Negative 8.57555. 5775. And from here on out, I'm just going to grunt things. Again, when I square root both sides, I have an I, which means that I have x plus 1.85 equals I root 8.5775. And I'm actually going to calculate that square root, just because I've already got decimals to begin with, so why not? I find the square root of, well, the opposite of this answer is going to be positive 8.5775. I get 2.93, which I'll call it 2.93. So subtract 1.85 from both sides, and I get negative 1.85 plus or minus 2.93. I can calculate both of those answers. There would be 2. Whatever they are, I don't really care right now. I'm going to do the last one. This is probably the key one for this video, actually. How long are we? Yeah, not bad. This is the first time we've seen one where the a value isn't 1. In fact, I'm actually going to change this problem a little bit, because we haven't yet done one where this is negative in here. I'm going to make that happen also. The a value isn't 1. That's the key thing here. B being negative doesn't change anything. We just haven't done one like this yet. You have to make the a value equal 1. If the a value isn't 1, you can't do it. Completing the square only works if the a value is 1. So the first thing I'm going to do is divide everything by 3. And I mean everything by 3. If this was a number besides 0, I would still divide it by 3. Everything is divided by 3, and I get x squared minus 5/3 x plus 10/3 equals 0, because 0 divided by 3 is 0. Now I do all the stuff I did before. Subtract the 10/3 from both sides, and I get that x squared minus 5/3 x equals negative 10/3. And I still leave this gap here like I always have been trying to. Right now my b value is negative 5/3. which means that b over 2 is negative 5 over 6. And so b over 2 squared is 25 over 36, and that's positive now. So I'm still going to do a plus 25 36 here. You're always adding something when you're completing the square at this step. It's always going to be addition. But when I factor the left side, it's going to factor still into this. Still factoring that b over 2 term. So it's going to be x minus 5 over 6 equals, I want to make these have common denominators, so they're both going to have 36's on the bottom. Well, this one stays 25. This is going to become times 12, so negative 120. So I get that x minus 5 over 6 squared equals negative 95 over 36. So I'm getting a lot of i's as I do this, but that's okay. Square root both sides. X minus 5 over 6 equals plus or minus I root 95 over 6. Now 95 can't break down as a radical. It's 5 and 19, and those are both prime. If it could break down, I would break it down, but it can't, so I won't. So I'm going to keep going. I add 5 6 to both sides, and I get that x equals 5 over 6 plus or minus I root 95 over 6. And there are my solutions. Hope you found those examples helpful. Thank you.